In this video we're going to introduce the idea of conditional probability. Suppose we've got a small car park in which there are 5 cars parked. 3 of the cars are red, 1 is blue and 1 is green. We'll let B1 represent the event the first car to leave is blue. Similarly, R1 represents the event the first car to leave is red, and G1 represents the event the first car to leave is green. Then we can write down the probabilities of these 3 events quite easily. Probability of the blue car as the first one to leave is 1 in 5. The probability of red car as the first one to leave is 3/5, and the probability of the first car to leave is green is 1/5. If B2 represents the event the second car to leave is blue, and similarly R2 represents the second car to leave is red, and G2 represents the second car to leave is green, then we cannot immediately write down the probabilities of the events B2, R2 and G2, since these probabilities are going to depend on the colour of the first car to leave. So, if we suppose that the first car to leave was a red car, then the car park would now contain 1 blue car, 2 red cars and 1 green car. So we could say that the probability the second car to leave will be green if the first car to leave is red will be 1/4. Or we could express that as the probability the second car to leave will be green given that the first one to leave is red is 1/4. And the shorthand for this statement is the probability of G2, that's the second car to leave, is green. Then we have the straight line as the shorthand for if, or given that, R1 has occurred. So we would read that as the probability that the second car to leave is green, given that the first car to leave was red, is 1 in 4. Similarly, we could say that the probability that the second car to leave, given that the first car was red, will be 2 in 4, or a half. And the probability that the second car to leave is blue, given that the first one to leave was red, is 1 in 4. Now, these probabilities, the probability of something happening given that something else has happened, are called conditional probabilities. And the phrases given that and if are typical indicators that a conditional probability is required. So, at this stage, just pause the video briefly and write down and answer this exercise. When you've answered that exercise, then continue with the video. Okay then. Now let's have a think about the ways in which the first 2 cars can leave the car park. Now if we're going to do that, we're going to need to be able to call each of the red cars something different, so we can identify each red car separately. So we're going to call the 3 red cars R alpha, R beta and R gamma. And let's suppose, just for convenience sake, they've got a little label on top of them. Then, the ways in which the first 2 cars to leave can be systematically listed. So let's suppose first of all that we've got the blue car going first. Then if we've got the blue first, then it could be R alpha going out second, or it could be blue then green, or it could be blue then R beta, or finally it could be blue then R gamma. Similarly, if R alpha goes out first, then the possibilities are R alpha then the blue car, or R alpha then the green car, or R alpha then the red car beta, or R alpha then the red car gamma. And we can continue the list, so we could continue the ones where green goes out first, or then when R beta goes out first, and finally when R gamma goes out first. So those are the 20 different ways in which the two cars can leave the car park. And as far as we know, each of these different ways are equally likely. So we can say that the probability that the first car to leave the car park is red and the second car to leave the car park is green is going to be any of the three highlighted possibilities. So we've got a probability of 3 out of 20. Now at this stage again, I'd like you just to pause the video and answer the 4 little questions that are here. When you've done that again, start the video up again. So, we've noticed that the probability that the first car to leave the car park is red and the second car to leave the car park is green is 3/20. Now the 3/20 could be thought of as being 3/5 times by 1/4, and 3/5 is the probability that the first car to leave the car park is red, and the 1/4 is the probability that the second car to leave the car park is green, given that the first car to leave the car park was red. And what we have here is a special case of the general multiplication rule for probabilities, which says that the probability of A and B is the same thing as the probability of A times by the probability of B happening, given that A has happened. Or we could express that as being the probability of A and B is the probability of A times by the probability of B happening if we know that A has happened. Now that rule you probably have used implicitly at GCSE, particularly with tree diagram questions. And in the forthcoming video we'll be having a look at tree diagrams as well. You may remember as well that in M2 it was seen that if A and B are independent events, then the probability of A and B is the same thing as the probability of A times by the probability of B. What we've then seen is that the probability of A and B is the same thing as the probability of A times by the probability of B, given that A has occurred. Putting those two lines together, we can cancel out the probability of A's, so we see that if we've got independent events, then the probability of B is the same thing as the probability of B, given that A has occurred. So we've got an alternative definition for independent events. The events A and B are independent if the probability of B occurring is the same thing as the probability of B occurring, given that A has occurred. And to finish this video off then, there's just one final exercise for you to work through, just using the techniques that we've mentioned during the course of this video. So have a go at this question and take your answers for all of these 3 short exercises into your next lesson, please. So that concludes our introduction to conditional probability.